Hi everyone, my name is Najla and today I am going to cover the topic on how to make your own salt crystal and share some of the theory behind it. So first of all, you're only gonna need two things, that is salt and hot water. For step 1, you need to mix a substantial amount of salt into the hot water until no more salt can be dissolved. It is important to use hot water as it helps produce a more concentrated solution. Salt dissolves in water due to its charge, where both water and salt molecules are polar. H2O is covalently bonded while NaCl is ionically bonded. And the covalent bond holding the water is stronger than the ionic bond holding the salt. When the positively charged hydrogen ions are attracted to the negatively charged chloride ions, the water molecules would pull the sodium and chloride ions apart, thus breaking the ionic bond. Then, the sodium and chloride ions are surrounded by the water molecules. Once all of the salt is dissolved, this results in a homogeneous solution. You would want to keep adding and mixing the salt until you can see undissolved salt collecting at the bottom, like so. For step 2, just pour a little bit of the concentrated salt solution onto a plate, and then we just wait for it to dry. As the water dries up, not enough water molecules can surround the sodium and chloride ions, causing it to come together again, forming salt crystals. And this is how it looks after some of the water has started to evaporate. Here you can see the result of my salt crystal experiment. You can see how it forms beautiful cubic-shaped crystals. The attractive forces are what made the ions come together again, which then results in a cubic-shaped crystal, or more specifically, face-centered cubic, FCC. Then, the crystal grows in a periodic array until it forms a fully grown crystal. Besides sodium chloride, there are some other elements that also have FCC crystal structure, such as copper, aluminium, and aurum. FCC has 4 atoms per unit cell. As you can see in the figure here, in FCC, 6 face atoms are shared by 2 cells. So, 6 multiplied by half gives us 3 atoms. And the 8 corner atoms are shared by 8 cells. So, 8 multiplied by 1/8 gives us 1 atom. Thus, in total, this sums up to 4 atoms. The coordination number of FCC is 12. Meaning that each atom in the FCC lattice is in direct contact with 12 neighboring atoms. So, 1 sodium ion is surrounded by 6 chloride ions and 1 chloride ion is surrounded by 6 sodium ions. FCC crystal has an atomic packing factor of 0.74, which is the maximum achievable APF, hence making FCC one of the close-packed structures along with HCP, hexagonal close-packed. To calculate the atomic packing factor, we multiply the atoms per unit cell by the volume of atom and divide by the volume of unit cell. And the volume of atom is simply the volume of sphere, that is 4 by 3 pi r cube. Next, as you can see, we calculate the A by applying Pythagoras theorem, where we take 4r square and making it equal to 2a square. Hence, we get the A equals to 2r sub 2. FCC structures tend to have relatively high densities due to its efficient packing. That is all from me today. Thank you for watching.